taking the time to sit down with me for this podcast. I have a number of questions for you. And first off, before we get into the conversation, I was wondering if you can tell me a bit about your background and what is it that you do at VMware?
Sure. Thanks for inviting me. My name is Dalia Malki. I'm a researcher. I'm part of a research group at VMware at the office of the CTO. We were established 3 years ago at 2014 when VMware felt that in order to meet the challenges and the threats of a future in which a lot of workloads migrate to the cloud, it needs to put a lot of emphasis on innovation. It's doing it in a variety of ways, and research, a dedicated research arm, is one of the ways in which VMware drives innovation. There's obviously innovation and inventiveness in VMware's culture throughout the R&D organization, right from the outset. And I'm personally a researcher with background in reliability, security, foundations of distributed systems, and with activity and contribution for longer than I want to admit, but let's say above 2 decades. My interest is in all algorithmic areas of distributed systems, reliability, and security.
All right, fabulous. Thank you very much. So today I'd like to talk about blockchain technologies and distributed ledgers. And I was wondering if you can just give me a background on some of the technologies and how they all fit together.
Yeah, so let me give you the 2-minute definition of the technology, and then we can branch into a number of directions like use cases and what are the technical underpinnings of the technology. So in a nutshell, what is a blockchain? A blockchain is a technology that allows collaborative decisions and information sharing among participants that don't necessarily trust each other, and allows them to execute collaborative logic, business logic, without actually trusting each other. So it allows you to construct services that previously were built on your ability to trust an institution or corporation, the business incentive that they have behind supporting such a service, and their own reputation and their own experience. This was all behind the trust you would put in a service. Blockchain allows you to do the same thing without putting a trust in any single institution or government or service behind it. So that's in a nutshell. That's the 2-minute definition I can give you.
Great.
And now we can dive into any technical direction that you would like to.
Sure. So blockchain has become top of mind to a lot of people, and it's more so with the public than ever with the rise of cryptocurrencies. Can you tell me a bit about how we got to where we are right now, and what are some of the use cases?
So blockchain emerged as the technology that allowed a cryptocurrency platform to track the provenance and the activity of digital assets. And it was developed and launched to solve that particular problem. How do you track the activity of digital assets, prevent the double spending of any digital value, and reach agreement among the public participants out there on who owns and where the digital asset is, and who has permission to spend it and to use it. So this is how this started. This was, of course, populated and publicized by Bitcoin. And it's still a very, very good technology for doing just that, for launching a digital coin, coupons, whatever you want to call it, and jointly tracking the provenance of those coupons. Everybody knows where they go, where they are, can track their activity, and how they're being transferred. And this led to a whole industry around just generating coupons and getting value out of that. But if we double click, if we zoom on the technology itself, at the basis of this technology is the idea of forming agreement on the history of actions that participants in a system would like to introduce to any kind of digital form. And in fact, this is a problem or a challenge that is not new in the technical world. So the academic world and the industrial world has looked at technologies that allow distributed services to be constructed such that there's agreement and there's replication and there's redundancy in the copies of this history of updates that you introduce to a particular service, and also a variant of it where the participants don't even trust each other or assume that some of them might be compromised or some of them may be penetrated by a hacker and be controlled by malware. So those technologies are referred to in the technical literature, in the technical community, as Byzantine fault-tolerant technologies, or BFT.
Okay.
And again, at the basis of them, they solve a very well-defined and very concrete problem. How to reach agreement, how to form agreement among in a distributed system among multiple participants on a history of updates to a particular domain.
Okay, and what are some of the mechanisms that are used to defend or prevent the double spend issue? How does that actually work?
So once you have a public global agreement on a ledger or a sequence of actions which are done and performed over your account or your digital assets, that's it. The problem is solved. So really at the core of all this technology is the ability for us to share this information and not to argue about what happened. Because really the double spending problem is you have a digital coupon of some sort. It's very, very easy for you to make 1,000 copies of that coupon and try to spend it over and over and over. But once we have one place, just like a normal banks or clearinghouses have today in the physical world, once you have a place where the only way you can spend that digital coupon is by recording it on a ledger, which is global and shared and agreed on by everybody, that's it. The problem is solved. And again, this is why the core of a blockchain is forming agreement and sharing on this ledger, this history of activity over. And I'm intentionally kind of leaving it opaque. What is this asset? What is this information? What are these updates updating? The original one, the Bitcoin blockchain ledger, recorded the transaction in Bitcoins. But more generally, this could be anything that you can express in a digitized form.
Okay, and how is the consistency of the blockchain managed? How do, for instance, with Bitcoin, miners come into play?
Yeah, so now we're getting into the solutions, and there are really a number of categories in the solution. The Bitcoin solution is a permissionless solution that allows unspecified population of unspecified size of participants to all form this agreement. And the way it works is using a crypto technique known as crypto puzzles or proof of work. It's using computation to moderate the pace in which proposed activity to the global ledger is throttled and is managed. And then everybody is incentivized to continue the longest standing ledger that they know of in order to win transactions in this ledger. So this is a permissionless solution. It's very scalable and it's very democratic. Nobody needs permission to enter this. Some of the downsides of this solution is it requires a lot of energy to participate. And it led to this arms race where in order to win this proof of work challenge, you need to spend a lot of computation. And there's a strong economical incentive, so that led to a lot of energy being dedicated to solving these puzzles. It's also, at the end of the day, not a solution that has any guarantee with it. Not just moving forward, but also looking backwards. There's no guarantee that at any moment in time, if the computation that you spend at a particular moment dominates the system, there's no guarantee that you cannot revert back any activity that was already considered accepted or finalized in the past. So this is a technology that is very interesting, very scalable, very robust so far, but has these downsides. Okay. So this is one category of solutions. People have been looking at the, so people are very, very excited about the functionality that the technology opened and raised awareness to, but we're looking for alternative solutions that don't necessarily use proof of work, that have better finality guarantees, and that maybe have better control over. And there's a spectrum of such solutions. There are solutions that borrow from the standard BFT literature, where the group of participants is actually permissioned. It's very well sanctioned. You can think of a consortium of organizations that join forces together and decide in a group to solve this problem. So you know who participates, you know their number, they don't just come and go at will, and the type of solutions, the type of BFT mechanisms that are possible in that setting are very, very different from the Bitcoin blockchain.
Okay, so since they are more structured and controlled, does that mean that there is less energy required to provide the proof of work, or do they use another mechanism in order to continue the chain?
Yeah, absolutely. So they don't rely on energy at all. What has traditionally been the safety keeper in such settings is the assumption that some fraction of them is in fact honest and not corrupt and not penetrated. So this is one way in which they can guarantee safety as opposed to proof of work. There's actually a spectrum of other solutions. So to marry together the economical incentives with the guarantees of BFTs, people have started looking at proof of stake, where it is a permission setting. You're working with mechanisms that are essentially designed for a closed permissioned group, but the permission is not really just by assumption or by design. It's something that has economical power behind it. And so the way you get permission to join the group and also to behave correctly in the group is tied directly to a stake that you put in the participation, in the form of actually putting a deposit of the relevant cryptocurrency and mechanisms to enforce that you lose this deposit if you are detected with any kind of misbehavior. And typically the idea is that the stake can be much, much higher than anything you stand to gain before being detected with very high probability. So there's this economical proof, if you like, that you have no incentive to misbehave. You will lose more than you gain.
Okay. And are there a number of organizations or enterprise consortiums that are currently employing this method right now?
There are. I wouldn't say organizations, but there are quite a few cryptocurrency startups out there that are already employing proof of stake mechanisms. Tendermint is one that comes to mind. Ethereum has announced recently that in 2018 they'll be moving gradually into a proof of stake mechanism that is actually operating in a very interesting hybrid mode, where the main ledger remains the public permissionless ledger, and then there's a proof of stake engine which finalizes and provides an extra stamp of approval for that public chain. So it becomes the authority, whereas the public permissionless Ethereum chain is going to become essentially a proposing mechanism. And down the line, they're also talking about completely switching over to a proof of stake type of mechanism.
Okay, since a lot of coins in the cryptocurrency market are based off Ethereum, how will this change in strategy or essentially fork of Ethereum affect these other coins?
So this is a very interesting question. So far, there hasn't been a colossal collapse of Ethereum or Bitcoin or any of the other cryptocurrencies. So in some sense, no news. It's just going to continue as usual, but maybe provide some protection down the line from something that might have happened. I believe that the full ramifications on the ecosystem and who will be stakeholders and how exactly it will play in terms of incentives and rewards, those are probably not fully understood yet, and time will tell.
Okay, and it seems like there's a lot of emerging use cases now that blockchain technology is becoming more and more common. Things such as supply chain tracking and so forth. What do you see as future use cases that would be beneficial or perhaps are emerging right now?
So this is a terrific and probably billion or trillion dollar question that the entire venture capitalist community would love to get an answer for. A lot of money, a lot of hopes, and a lot of activity is put into this space. I can give a somewhat technical answer. This is not the perhaps business business answer that you were looking for. And it definitely won't tell anybody who listens to this how to go off and make money with it. But from a technical point of view, I view the technology as providing an opportunity and a mechanism that allows you to remove trust from a service that you construct in 4 levels. And really, this is the promise that everybody, I think, is seeing, and the excitement about this. So at the bottommost level, we already discussed the ability to share a ledger of transactions, asset transfers, a very well-defined and prefixed format for cryptographic, money coupons. And that's very, very nice. And like we said, there's a whole industry of ICOs now living off of that. But that's really just the bottommost level of what the technology is capable of. Once you're aware of this ability to form a service where you share not just the final result of a money transfer or currency transfer that you decided on, you realize that, first of all, you can agree on a sequence of transactions that are much, much more complicated than just A transfers some amount to B, which is really what the Bitcoin blockchain allows you to do. So the next level is a level where the service that builds collaborative logic shares slightly more advanced forms of transactions than just, A transfers amount to B. And to give you a completely silly example, but from a computer science point of view, a very powerful one, what I can share is something like a queue. Okay? We can regulate arrivals so that if you and I arrive at the same time and append something to a blockchain, then you will get number 14 and I will get number 15. So this is the actual action that we put on the chain, instead of being the final form of, okay, you decided to pay somebody else and this is what you append, you actually let the chain decide for you what is the next ticket number, and if two of us arrive at the same time, you will get 14 and I will get 15. But you'll notice that there's already something active going on the blockchain itself. All you said is, I want the next ticket. You didn't know what it is, you didn't know what amount, what number it is. You've essentially put an active action on the chain itself, on the blockchain, and it gave back the result. In this case, it was a very simple, silly example. The action was just an increment. We have a single counter. You've incremented it, so it was 13 before you arrived, and now it's 14. When I arrive, I get the current value, which is 14, and increment it to 15. But from a computer science point of view, what that means is that I can put any type of action, and the blockchain decides on the ordering in which we execute these pre-specified actions. And these actions could be as expressive as you like. So this is level 2.
Okay.
We were at level 1 before, this was level 2. And we don't stop there. We get to smart contracts. So what are smart contracts? So just like we can pre-specify very, very simple transactions, we can pre-specify slightly more elaborate transactions. The next level is what we pre-specify is a full Turing machine execution engine, which every block in a blockchain executes, and the user decides what program to actually execute. So it's completely flexible, completely programmable. And now what you get to is that the blockchain orders the sequence of actions which are executed, but what these actions are is completely flexible, completely programmable. And this allows users to build shared execution engine in a completely programmable, completely flexible manner, without any single service behind them, any provider behind them, without any authority, and without anybody being able to control or prevent or revoke or reject or censor anybody else. And this is the ability to execute smart contract logic, and the blockchain orders and forms agreement on what is executed and what are the results. So this is layer 3. Remember I told you we have 4 layers. So we're gradually removing trust from what traditionally services needed to execute in a centralized manner before. So we're now able to build this complete service from scratch without trusting anybody in a completely collaborative manner. But one thing is still missing, and that is security and privacy. And this is something that traditionally you need to trust a mediator or trusted third party for bootstrapping your key management, for managing privacy, and so forth and so on. And this is the 4th layer, and perhaps the most exciting, is where the blockchain can actually allow you to manipulate and process private data and to prove the results of operations and manage credentials without bootstrapping by any centralized authority. And we see a lot of activity in that layer as well. So again, 4 levels in which traditionally the only way to build these software services was for a corporation to put its reputation, its business incentive and its strength in supporting it in order to bring up those services. And at all 4 levels, you can now defer all of this implementation to a blockchain. This is from the technical point of view. What are the actual use cases, whether it will be supply chain, health organizations, sharing data for joint analytics, IoT devices, management, identity management. There are 4,000 of them and more popping up every day.
So VMware is actively doing some research into this, as it's quite apparent. Is VMware contributing back to the community the work that they're doing on any open source or collaborative projects, or are there just some internal research and vision going on within the organization?
So VMware is very well positioned in this space for 3 reasons. One is we have a lot of relevant customers in the enterprise world, financial world, governments. We drive the IoT and workloads of the world's workloads. Secondly, VMware has experience and credibility in building distributed software and deploying it and selling it. We're not operating only services from our own clouds, our own services. We actually build distributed systems. And thirdly, we have the research team. We have a team of experts with combined expertise, credentials, contributions in the relevant arenas for over combined 100 years of research. And these systems are not for the faint of heart. You really need a lot of technical strength in order to get them right. So VMware is wonderfully positioned to lead in this space. And what we hope to be is the most secure, the most reliable, the most high throughput, the most expressive place to run any blockchain workloads that will be out there. We do publish a lot of our work, and we will also have a lot of offerings in the open source space, as well as our own tools and proprietary technologies.
Now, I believe that there's a blockchain-related VMware Fling that's out there right now. What can you tell me about that?
That Fling mostly has to do with management of said distributed tools. One of the strengths and experiences that VMware can offer in the space is the experience and strength in managing distributed software, not just our own, but also third-party distributed software. So even just deploying, managing, doing the DevOps, the orchestration, the monitoring of distributed software is a very, very tough problem, and this is what that Fling is doing. It's doing it currently for the Linux Foundation Hyperledger technology, and it's contributed as an open source tool.
Fabulous. Well, thank you very much for your time. It's been wonderful speaking with you, and we definitely look forward to see what VMware is going to be announcing, hopefully sometime in the near future.
Thank you.
Great, thank you.